Okay, this video is section 4.5, which we start talking about continuous growth. And anything when you hear the word continuous growth is base E. So if you see the word continuous, it's always base E. And I know you've watched the videos, and the video talks about E being the continuous exponential function. It's 2.71, and just make sure you watch the video so you can understand what's going on. So the first one says a population grows from its initial level of 22,000 at a continuous growth rate, so I know it's base E, at 7.1% per year. Find the formula. So the first thing I want you to remember is if it says continuous, the formula is y equals AE to the KT. And the other thing that's cool about this formula, that if it's growing, if it's positive K, if it's growth, it's a negative K if it's decay. And you don't have to worry about the 1 plus the rate or the 1 minus the rate. You just have to make sure it's positive or negative. So because this is growing, it's going up. When I go to do this, I said use P for population. The initial town population was 22,000. E, it's growing 7%. All you gotta do is make sure you move your decimal place, so it's 7.1%, so it's 0.071 to the T. It's as simple as that. So sometimes, even though I know this is different, sometimes continuous growth is a lot easier to come up with the formula. Now they say, by what percent does the population increase each year? So again, the word here is annual. And I just want to remind you that the annual growth rate is base B. So if I used y equals AB to the T, and then I wrote the continuous formula, y equals AE to the KT, the A's match, the T's match, the B and E to the K are equal to each other. This is, again, the annual, or 1 time per year, and this is our continuous. So if they ever ask you, what is the actual percent increase? The continuous increase up here, the continuous growth or continuous increase was 7.1%. But because it's continuously growing, your actual annual increase is actually going to be more. So all you do is you say B is going to equal, B is going to equal, I was thinking ahead here, E to the K, because that's what they're equal to each other. So I said, okay, I'm just going to convert it to B and say E to the 0.071. And when I put that in my calculator, B comes out to be 1.0735. Subtract your 1, so that, and move your decimal place, so that's 7.35% annual growth. Okay, so how would I actually explain this? So continuous growth, which is base E, has a higher annual percentage because of continuous, and I'm going to be really loose with this term, like compounding. It's kind of like compound interest. You're getting interest on your interest. Well, that's what continuous growth is. You're growing, and then it's people are having babies, and then babies are having babies. So it's almost like a continuous compounding effect. So this is really, at the end of the year, this is really what it grew at the end of the year, even though it was continuously growing 7.1%. So let's look at number 2. A radioactive substance decays, so it's going down, at a continuous rate. So that means it's going to be e to the negative k. The k is going to actually turn negative, and it's 14% per year. So I'm going to change that to 0.14, and a 50 milligrams of the substance is present in the year 2009. Time is 0. Do you see how you do this? This is my A. You just go through and just kind of label everything, and then it works out better. So now it says write a formula with A. So I know it's y equals a e to the kt. So they want us to use A instead. My initial value was 50 milligrams. E is continuous. K is going to be negative 0.14, and then T. So here's my formula. This is my amount in milligrams, and this is my time in years since 2009, because that's when time was 0. So what do they ask for us next? How much will be present in 2019? Make sure that you show me the subtracting. Take the 2019, subtract the 2009, because that's when time is 0. That's 10 years. That's what you put in your formula. So I'm going to say my amount after 10 years is going to be 50 e to the negative 0.14 times 10. So that's going to be 12.329 milligrams. And I knew it was going to be less because it's decreasing. And the last part is kind of like what we've been doing for a while. It says estimate when the quantity drops below 5. Make sure that you put a 5 in the spot. You show me the actual formula that I start out with 50. I'm now going to 5 of my formula, and they want to know how long it takes to go there. So when they say when, we're looking for time. So you don't know how to use that. You actually need to use logs. So set it up for t equals, and then you're going to show me a picture. You're going to actually graph this. Make sure that you practice this. I'm using Christmas colors again. So here's my time in years. Here's my amount in milligrams. You start at 50 and you're going to decrease. That's what it looks like. And you want to know when there's 5 left. So we'll say 5 is here. And you graph the left, graph the right, and see where it crosses. And when you do, you get 16.5 years. Please make sure you practice that so that you can solve that. That's exactly how I want you to do it. So that's all there is for this. I hope to help, and we're going to do some more practice in class.